guys, today I'm going to talk about polyatomic ions. Right now I'm just showing off my little camper. That's where I was this weekend. Anyway, there I am. We're going to be doing polyatomic ions. Let's see if our helpers are here. Who's our helpers? Nina, Bella. I think they're ready to help. Come on, let's go. So polyatomic ions. Poly means many. Atomic means atoms. Ions means with a charge. So polyatomic ions are many atoms with a charge. If you look on the back of your periodic table, you should have a list of polyatomic ions. Here they are, and they're listed by their charges. There's ammonium with +1, acetate, hypobromate, bromite, bromate, bromite, perbromate, hypochlorite, chlorite. And here's the -2 ones: carbonate, chromate, dichromate, silicate, sulfate, sulfite, and -3 charges down there. So these are all ones that have many different atoms, and they're all nonmetals, so they're covalently bound together. They're covalently bound together in such a way they have extra electrons and a negative charge. The names of most of your polyatomic ions end in "ite" or "ate." That's why I say on your periodic table right here, you should write ites and ates. So if you see a chemical name that ends in "ite" or "ate," this is where you're going to be looking. Most of the names have "ite" and "ate" in them. Most of the polyatomic ions have oxygen in their formula. This is nitrate, which is NO3, sulfate, which is SO4. And if you look at the chemical formulas for all of these, almost all of them have oxygen in them. All the polyatomics have a negative charge except for ammonium, which means they're all going to be at the end of the formula or the end of the name. Because remember, the positive ion or the metal ion goes first. Okay? Now, ammonium Nh4. It is one of the few positively charged polyatomic ions, which kind of brings us to, you remember we said, is it ionic or covalent? And I said, well, if it starts with a metal, it is ionic. That's true. But if it starts with a if it starts with a non-metal, then it's covalent, unless it starts with ammonium. The first element in ammonium is nitrogen. So even though nitrogen is the first element and it's a non-metal, if it starts with ammonium, it is an ionic compound. And another thing, hydroxide, a very, very common polyatomic ion. We find hydroxide in chemicals known as bases, which are kind of like the opposite of acids, and we're going to talk about them later. But hydroxide is one of those polyatomic ions that always gets messed up or forgotten. So even though it says hydroxide, its formula is OH. The O goes first. And it has a -1 charge. Okay? Another thing we want to look at when we look at the formulas for these polyatomic ions, we notice in the formulas of polyatomic ions, there are subscripts. Okay? Like here we have BrO4. Okay? ClO3. Those subscripts are part of the polyatomic ion. We do not change the subscripts in the formula of the polyatomic ion. So now what we're going to do is we're going to look at naming and formula writing using these polyatomic ions. It sounds confusing at first, but really we're just going to be doing the same thing that we've been doing all along. Okay, so this is assignment number 3, polyatomic ions. So we're going to do this the same way we did the other one. The first part, we're going to go from the name to the formula. And on the second part, we're going to go from the formula to the name. Okay? So going from the name to the formula, you remember our 4 basic steps. Step 1, symbols. Step 2, oxidation numbers. That's the charges. Step 3, we crisscross. And step 4, simplify if necessary. Okay, so let's do that for number 1, zinc sulfite. Okay, so the symbol for zinc, find zinc on your periodic table, is right here, number 30. Notice that you should have a +2 for zinc. Zinc is always +2. Okay, so zinc is a +2. Now we look at sulfite. Okay, sulfite. Now we know it ends in ite, so we're going to look at our ites and ates, and we're going to look for sulfite. And we're going to look, and we're going to look, and we're going to look, and then we find here it is sulfite. Sulfite is SO3 with a -2 charge. So it is SO3 and has a -2 charge. Okay, now we get to the part where we're going to crisscross the charges. Okay, now remember this 3, we are not going to do anything to that 3. It's part of the sulfite ion. So that 2 comes over here, and that 2 comes over there. We see that the 2 simplify, so our formula is just going to be ZnSO3. Okay, and that is zinc sulfite. Now, I'm going to show you something, and this is why it is very important that we call chemicals by the right name. Okay, so I'm going to do zinc sulfide. Remember the ide side? If it ends in ide, it's over here. Okay, zinc sulfite and zinc sulfate. All right, so zinc sulfide, that's going to be zinc, and it's a +2. Sulfur is a -2. Remember, sulfur is in group 16 or 6A, so it's going to have a -2 charge. Don't forget these charges up here. It's on the ide side. So this one's just going to be ZnS. Okay, zinc sulfite, we just did sulfite, and it is SO3 with a -2 charge. The 2's cancel out, and that is going to be ZnSO3. Okay, now sulfate, when we look at this, and you'll notice there is a pattern between the ites and the ates. The ate will have one more oxygen than the ite. Okay, so just in case you're wondering, the most common polyatomic ion gets named the ate, and one with one less oxygen is the ite. And if you want to see the full progression of this, look at chlorate. So here's chlorate, one less oxygen is chlorite, another less oxygen is hypochlorite. Then we come over here, one more oxygen than chlorate is perchlorate. And so if you see a polyatomic ion with names like that, sometimes you can figure out what they are. Sorry, I wasn't even on the camera there, but I was looking at these: chlorate, chlorite, hypochlorite, and perchlorate. All right, so let's go back to sulfate. And here's sulfate, which is SO4 with a -2 charge. So all of these combine in a +2, -2. They combine in the same ratio. So we see that sulfide is this, sulfite is this, and sulfate is that. That's why it's very important that we write the correct name for the chemical. Different chemicals have different properties, and just changing one letter, the D to a T, changes the chemical formula. It's a different chemical, so we have to write them properly. All right, let's get back to our worksheet here. Hydrogen nitrate. Hydrogen is H, and we look on our periodic table. And hydrogen is going to be a +1. And then we look at nitrate. Hey, that ends in 8. Let's look at our ites and 8s. And we'll look for nitrate. And we see, by the way, they're listed by charge, and they're also listed alphabetically. So here's nitrate. Nitrate is NO3 with a -1 charge. So +1, -1, when we crisscross the charges, that means a 1 comes over here and a 1 comes over there. This is just going to be HNO3. Okay, sodium phosphate. Guys, do not forget the symbol for sodium is Na, because its Latin name used to be natrium, and sodium is going to be a +1. Also, when you're writing chemical symbols for your elements, first letter is capitalized and the second letter is not capitalized. Okay, phosphate. We see that ends in 8. And so we're going to look at our ites and 8s, and we're going to look for phosphate. And here it is in the -3s, and it is PO4. Oh, forgot the charge on it. It is, phosphate is PO4 with a -3 charge. All right, now we crisscross our charges, so that 3 is going to come over here, and we get Na3PO4. Okay, I'm going to skip down to number 6, iron 2 nitrate. Now, as you recall, for multivalent cations, iron 2 is going to have a +2 charge. Remember, this Roman numeral tells you the charge. And nitrate, we look at our ites and 8s, and we find nitrate is NO3 with a -1 charge. Now we're going to do the crisscross. So that 2 is going to come over here. Now here's the thing. We need 2 nitrate ions. So we have to put this into parentheses. Don't change the 3. Don't multiply the 3 times the 2. But we need 2 NO3s. So it is Fe. And there's a 2 outside the parentheses there. Okay, so if we were able to see ions, we would see that there's an ion for iron 2. And it's right there. And then we'd see a nitrate here with its -1 charge. We would need 2 of those. +2 -2 equals 0. Then the charges have to balance out. So we need 2 nitrate ions. And so a nitrate ion would work just like any other -1 ion, like chlorine or fluorine. It's a separate unit. So we don't do anything to the 3, and we keep it together as an NO3. That is the nitrate ion. Okay, so that's how you do formula from the name. Now let's look at the other part, and this is pretty easy. We're going to go from the formula to the name, okay? So here, you write the name of the metal, and 2, you write the name of the polyatomic ion. That's it, unless there's a multivalent cation, okay? So, if there's not a multivalent cation, we just write what it says. Now, remember, your polyatomic ions are negative, and so they're going to be at the end of the formula. Okay, the metal is going to go first. All right, so we see here we have KNO3, and the symbol K is for That's right, potassium. So we write potassium. And then NO3, we recognize that as a polyatomic ion. So let's look at our list of ites and eights. And we look for NO3, and there it is right there. NO3 is nitrate. So that is potassium nitrate. Okay, number 15, Al, is aluminum. NO3 is still nitrate. That's it. Now, manganese, careful here. Manganese is multivalent. Manganese is going to need a Roman numeral. Okay? And so we need to know, is it manganese 2 or manganese 3? And this is where we do this. We make the cross, and we'll look at SO4. What is SO4? Well, let's look at our ites and eights, and we see SO4 is right here. It is sulfate. It has a -2 charge. So if there's a -2 charge, this one has to have a +2 charge. That is the charge on the manganese. So this is going to be manganese 2 sulfate. So let's go through the list here and let's make sure we know which ones are going to need a Roman numeral. In other words, which ones are multivalent. So calcium. Calcium is in group 2. It is not multivalent. Sodium. Sodium is in group 1. It is not multivalent. Hydrogen. Group 1, not multivalent. Iron. Well, look where iron is. And you should see +2, +3. We need to know which one that is. So here, we need to do this. All right, this gets a little tricky here. So CO3, what is CO3? Well, we know it's a polyatomic ion, so let's look over here on our list, and we find CO3. Well, there it is right there. Carbonate. CO3 is carbonate and has a -2 charge. All right, so each carbonate is a -2, but how many of them are there? There are 3. So that gives a -6 charge. So this is a +6 here. And that +6 is coming from 2 irons. So each iron ion must be a +3. So this is iron 3 carbonate. All right, so this one's multivalent, that one's multivalent, and that one's multivalent. Those are the only ones that are going to require Roman numerals. And those are really the hardest ones because you have a polyatomic ion and you have a multivalent cation. All right, so I'm going to put this on high-speed camera and I'm going to work through the rest of them. One thing I may have forgotten to mention, anytime there is a subscript for the polyatomic ion, like if we crisscross and that 3 comes over here, the polyatomic ion must be in parentheses. Okay? So we need to have, this shows that we need 3 nitrate ions. We need 3 NO3s. So anytime there is a subscript next to the polyatomic ion, like here, 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 or here, we have to put the polyatomic ion in parentheses. Remember, do not change the formula of the polyatomic ion. Okay, so that's assignment number 3, ionic compounds with polyatomic ions. So remember, when you're looking at the name, you will oftentimes see ite or ate. And polyatomic ions are negatively charged, so it'll be the second word in their name. Also, when we're looking at the chemical formulas, we're going to see 3 or more capital letters in the chemical formula. If you only see 2 capital letters, that's binary. In other words, only 2 elements. But if you see 3 or more, that means a polyatomic ion is there. Most of your polyatomic ions also have oxygen in their formula. All right, let's see how our helpers are doing. Bella, where are you at? Bella. She was snoring just a second ago. And Nina left. She's not here. Anyway, I hope you did good with that. Email me if you have any questions. Bye.